Hello there, you beautiful people. Now, it's very common when we're working with logic to want to combine multiple conditions into one. And this is where logical operators come in. In this lecture, you're going to learn about the not, or, and logical operators. So by the end of this lecture, you're going to know what these powerful operators are and how and when to use them. This is useful basically everywhere in logic. In fact, without knowing about logical operators, you won't be able to do much real logic at all. So with that, let's get into it. So the first question is, what the heck are logical operators? Well, first of all, logical operators are different to comparison operators. Comparison operators like greater than, less than, equal to, and all those things we covered before, are used to compare pieces of information to make conditions. Logical operators, on the other hand, combine and modify the conditions to make bigger conditions. So comparison operators make conditions, logical operators combine the conditions together. So I'm going to start off by showing you the not logical operator. This is the simplest logical operator and basically gives you the opposite of what the condition would have been otherwise. So for example, not, you can see the way that it's gone yellow, not true gives false, not false gives true. So like for example, if I had not 2 less than 3, okay, 2 less than 3, what's that? That's true, right? So not true, false. What about not 3 greater than 1? Actually, that's going to be false again. Now, what about not 4 equal to 3? That's going to give true, because 4 equal to 3, that's true, not true, false. Now we can use these logical operators in if statements. So for example, if I had x and I set that equal to 10, and I had y and I set that equal to 20, now if I wrote the if statement, if not x less than y, actually no, if not y less than x, then print it worked. And we're going to see it says it worked. And the reason why, well, is y less than x? Is 20 less than 10? No, right? So that would come back as false. What's not false? True. So this whole condition here became true, and therefore this code worked. So you can see the way that the logical operator has managed to modify the condition in a rather simple way. Now we can actually represent this behavior in what's called a truth table. So down here I have a diagram of a NOT gate, or like a NOT operation. This is how they're drawn in circuit diagrams and things like that. So we have an input called A and an output. And instead of writing true and false all the time, but in these truth tables, people write 0 to be false and 1 to be true. And what you can see is that if A, or the input, is false, the output is true. And likewise, if you have the input is true, then not A, or the output, is going to be false. So basically, the NOT gate just gives you the opposite of the input, right? So with that out of the way, let's have a look at the AND operator. Now this is the truth table for the AND operator. You can see that unlike the NOT, which only had 1 input, AND has 2, right? So you've got A and you've got B, and you get 1 output. So the key thing about the AND is that it only gives you true if both of the inputs are true. So if A, another way of saying that is if A and B are true, then the output will be true. That's why it's called the AND gate. So if you look here, if A is false and B is false, you're going to get false. If either one of them are true, you still get false, but when A and B are true, you get true. So that's the AND gate. Let me show you an example of this in our Python code. So as an example, let's say we have C is equal to 10, and we have D which is equal to 5. Now if we have an if statement like this, if C is greater than 10 and D is greater than 1, print it worked. Now, why didn't that work? Okay, the reason why it didn't work is because, well, let's break it down. Is C greater than 10? It's not, right? Because C is 10. Okay, so is 10 greater than 10? That's false. So we've got false here. Okay, I'm just going to write this. False. We then have and now what have we got here? We've got D greater than 1. Is 5 greater than 1? Yes, it is, right? So true. Now remember, when you have, this is basically input A, and this is input B. Only if both of those are true will you get true. Okay, so at the minute, we've got false and true, which is false overall. So this overall is false, which means the if statement won't run. Now, if I change it so that if C is greater than or equal to 10, okay, now is 10 greater than or equal to 10? Yes, it is. Okay, so we're going to get true for that. And is 5 greater than 1? Yes, it is. So we're going to get true and true, which is overall going to be equal to true. So this whole thing is going to be equal to true, which means if true, that means the whole code inside is going to run, doesn't it? So if I click that, there we go. So now because both of the conditions are true, our code will work. So now I want to show you something that might blow your mind a little bit. Okay, we can combine not and together. Okay, to make a NAND, basically a not and. So let me show you what that is. At the minute, we've got this working, don't we? So what I want to show you is if I change C. Let me just take this and just make it just like it was before, right? So this won't work. Okay, because we have false and true. Okay, that all comes to false. Right, you're with me so far. This is exactly what we had at the top here. So what I'm going to do is I'm going to type if not, and then put in brackets like that. Okay, print it worked. So let's have a little breakdown of what this is going to do. Okay, now you remember from the BODMAS and math stuff that we did before, whatever's inside of brackets is going to be executed first. So let's start there. Is C greater than 10? Is 10 greater than 10? That's false, right? So that's going to be false. Is D greater than 1? So is 5 greater than 1? Yes, it is. So that's true. What's false and true? That's false, right? So this whole bracket here is going to be false. So this whole bracket here is going to be false. But what's not false? True, right? So now overall, just by putting the not there, it works. Even though we had the same and condition here as we did here, by taking the not of that, we managed to get the code to work, which is very useful. So the point that I'm trying to get across to you there is the way that you can use brackets to allow operations or logical operations to happen on each other, right? So we used a bracket here to say, take the not of whatever this bracket is, right? If I didn't have the brackets, what would happen is it would take the not of this and this. So that's super confusing, right? But it's the difference between taking the not of the whole thing and taking the not of just this one on the left. By putting the brackets, we say take the not of the whole thing. Without the brackets, we just take the not of what's on the left. So I know that's a bit confusing, but with practice it makes sense. So in the interest of time, I'm going to cut this video short because we've just got one more logical operator to come on to, which is the OR operator. So I'll see you in the next video to talk all about the OR operator. Hello there, you beautiful people. So the final logical keyword, the final logical operator that we have is the OR operator. So what the OR operator does is it gives us true if input A or input B are true. So as we can see from the truth table, it gives us true if either one of A or B or both of them are true. So if B is true, you're going to get true. If A is true, you're going to get true. If A and B are both true, you're going to get true. But if they're both false, then you're going to get false. So basically, OR is a very forgiving type of logic. So you use it if you just want to check whether any of these conditions are true. So let me show you an example. Okay, so let's create a variable called C, and let's set that equal to 5, and D is going to be -1. So let's have our logic, our if statement, say if C is greater than 1, or in lowercase, sorry, or D is greater than 1, then print it worked. And that worked, right? So let's see why. So is 5, well, first thing it's going to check is C greater than 1? C is 5, so is 5 greater than 1? It is, right? So we're going to get true. Then you've got OR in the middle. Now, is D greater than 1? Is -1 bigger than 1? It's not, right? So that's going to be false. But because one of the inputs to OR is true, the overall thing gives us true. So that means the condition here is true. If I had C, let's say if I had D is equal to 5, right? And had if C greater than 1 or D greater than 1, print it worked. Okay, so C's 5, right? Is 5 bigger than 1? Yes, it is. Okay, so we get true for that. Is 5 now, because D's 5, is 5 bigger than 1? Yes, it is. So now both of these conditions are true. And that also gives us true. The only way that this will fail is if both are false. So if I said if C is greater than 100 or D is greater than 100, print it worked. I can't spell. It worked. That's not going to work, right? Because C is 5. 5 isn't greater than 100, so you get false. And D is 5. 5 isn't greater than 100, so you get false. False or false? False. Okay, so that's how the OR operation works. Now you can combine this with the NOT, just like we did with the AND. So take, for example, if I did this, we know that that doesn't work, right? That comes false. But if I did a NOT here and put a bracket around all of this, now I'm saying take the NOT of whatever this gives. We know this gives false, so what's not false? It's going to be true, right? And now it's going to work. So that's how you can combine together NOT and OR to create a NOR, basically, which just gives you the opposite of what the OR would give. So combining together all these operations is how you make really, really powerful operations of your own. So let me show you a rather complicated example to show you what I mean about how you can combine these operators. Okay, now this is rather heavy, so bear with me, but it's going to show the point. I'm just going to give us some space here, and I'm going to create C equal to 6, and D is 2. Okay, C is 6 and D is 2. And I'm going to write this condition. If C is greater than 5 and D greater than 5, or C greater than 1 and D greater than 1, print it worked. Now I'm not going to press enter. I'm just going to walk you through what answer this is going to give. Okay, so let's start on the left, because that's how these things work, right? Let's start on the left here. C is 6, so is 6 greater than 5? That's true, right? That's going to be correct. Okay, so we've got true here. Is D greater than 5? No, it's not, right? Because D is 2, and 2 is not greater than 5. So we've got true and false. This whole bracket here is going to be false. Okay, so we've got false on the left side of an OR. Now on the right side here, we've got C is equal to 6. So is 6 greater than 1? Yes, it is. So that's going to be true. Now we've got D greater than 1. Is 2 greater than 1? Yes, it is. So this is true and this is true, which means this whole bracket is true. Okay, so we've got this whole bracket being false, this whole bracket being true. What's false or true? That's going to be true, right? So if I press enter, it worked. Okay, so this whole bracket became false, as I showed you. This whole bracket became true. False or true gave true. The whole condition was true, which means this code was ran. So I know that was a bit hardcore, but that's how these conditions are combined together to make more powerful conditions. What we'd be checking is if they're both bigger than 5 or they're both bigger than 1, run this code. Okay, so in plain English. So that's a very powerful ability to be able to combine all of these things together. And actually, to be honest, you could go another level if you really wanted, just for example purposes. We know that this works, right? That works. But I could make it not work by putting a bracket around all of this. I could make it not work, putting a bracket around all of it and typing not. Okay? And now that won't work because it was true. Not true is false. So now this whole condition is false and it didn't work. So you can combine and mix and match these operators as much as you like, which is a massively powerful ability. Phew, well, after all that logic, my brain is starting to hurt. So let's have a quick recap to make sure that we've got it all. So in the last lecture, we started looking at the not condition. The not condition basically reverses what you'd get otherwise. So not true is false and not false is true. Simple. After that, we had a look at the AND condition. The AND condition only gives you true if both inputs are true. So if A and B are true. Then we had a look at the OR condition. The OR condition gives you true if A or B are true. So if either of the inputs are true, OR is going to give you true. It also gives you true if both of them are. So OR is like a more flexible AND. Now we can combine these NOR and OR. Oh my god, that's so confusing. But you can combine these three conditions to make more powerful conditions like the one that we saw here. Now obviously this is a lot to take in, and the best way to do it is by practice and try and get in real life in your code. Trust me, when you know what you're looking for and what you're trying to program, all of this is really easy to do. So to help with that and to help give you some practice, I've got a multiple choice quiz up next to help you solidify the concepts, and then after that we're going to have a section review and move on to the data structures section of the course, which lend themselves very well to being worked with logic. So we should have some quite good practice there. So up next you have the multiple choice quiz, which I wish you the best of luck with, and I'll see you in the section review.